All right, a nice way to start chapter 7 is, or what I like to, is this little pattern. What is the next picture in the pattern? If you want to stop the video and think about it, go for it. Some people get it right away, some people never get it, but it's kind of fun. So I'm going to show you the answer right now, and it has to do with the section we're on, rigid motion in a plane. So as you can see, you take that number, and if you do a little reflection to the left with the number, you get that little pattern. A little bit different than what you normally see. So chapter 7 is all about just transformations that happen in 2 dimensions here. First off, we want to get some vocabulary out of the way. The image is the figure. Okay, that's where we start. You start with some sort of shape, or excuse me, the resulting figure. And the pre-image is what you started with. Apologize about that. It's the original figure. So we start with a pre-image, and we usually move it into a new image. A transformation is any type of operation that maps, is kind of the mathematical term we're going to be using, which just basically moves. It moves it from the pre-image onto the new image. And an isometry is a specific type of transformation where it preserves lengths. It also preserves angle measures, parallel lines, and distances between points. But this one preserves length as the big one. And now there are types of isometries that we're going to be talking about. The first one's a reflection. It's kind of like a mirror image, where in this case we take the word geometry and we reflect it over this line, and that's the mirror image, or the reflection. Okay, so when you do a reflection, you always have some sort of line that you're reflecting the image over. And as we get into the later chapters, we'll talk about how you actually make a reflection. But notice these lengths, and this length is going to be the same. This length and this length are the same, and these are right angles. So we'll actually be able to do this by hand. Another type of isometry is a rotation. Okay, you're spinning the object. Here we're rotating this object, basically, I suppose, at the bottom of the Y to the top of this Y. So this is a 180-degree rotation. So you rotate a certain direction clockwise, 180-degree clockwise rotation about this point. And I could do a different rotation. Here, this rotation might be 120-degree clockwise rotation about this point. The third major type of isometry, a specific type of transformation where length is preserved, and all is a translation. Okay, a translation is like a slide. I'm just taking this and sliding it over. Okay, you're moving all the points in the same direction and same distance. And we could show you how this is moving in the same. Notice the tip of this G to the tip of that G. And if I pick a different point down here, put it on the top of the M, notice it should go to the top of the M. It's a little bit off, but it's a little bit off here too. So bottom of the Y, all these points are moving to the same spot. Okay, so all the points are going the same distance at the same angle. Identifying the transformations, this first one, you want to be careful because they can be a little tricky. You might look at this and get it right away, but if you think it's a reflection, imagine drawing in your line of reflection. Is this the line that's being reflected over? And I'd look and I'd say, it's not quite right. So it's not a reflection. If you did a translation, or am I just taking this point thing and moving it over? That doesn't quite work. What's going to work better is if I rotate it about, got some dots here I want to clean out of the way. There you go. About here, I'm guessing. Okay. If I spin it about here, and I probably should make it over here a little bit more. But this point is going to spin up to here. This point is going to spin down. It's kind of doing a rotation this way. So the first one is a rotation. The second one, I look at this and it's clearly, I'm just sliding it this way, right? Sliding this pre-image onto the image. So that's what we call a translation. And the third one, okay, this one, you might think it's a rotation. A lot of people get the rotation and reflection backwards, but if I draw in a line of reflection about there, you can see how this point is going over, this point's going to this one. Okay, it gets a little bit unclear at times, but this is a reflection. And one way to make this clearer is to use a notation. So the notation we're going to use is triangle ABC. This is what we're going to call the pre-image. That's where we started. Goes to the image A prime, B prime, C prime. Okay, so that means prime. Okay, A prime triangle ABC gets mapped to triangle A prime, B prime, C prime. So we want to describe this transformation. Transformation is the general term for a mapping. And I look at this and I look C, C prime, B, B prime, A prime. And so this is a reflection. Okay, and we also want to describe the line it's being reflected by. So it's a reflection over the y-axis. Now the next one is a translation, because we are sliding the points. We're sliding the points over 3, 6, 7 units. 7 units to the right. And up 1 unit. And does that work for, so that was A to A prime, over 7, up 1. But this also is true for B to B prime, over 7, up 1, or from C to C prime. Okay, notice I started at the image, right? Or excuse me, the pre-image. Why is that the pre-image? Because primes mean the image, right? Since this has the primes, this is the image. Okay, so if it was different, if this was A prime and this was A, it would be down 1, backwards 7. So it's important to recognize which is the image, which is the pre-image. So here, this is our pre-image image. We are doing a rotation, C to C prime. Gotta make sure my rotation works out. It's kind of something you develop, but I'm looking at this and I want to keep this length that it's spinning has to stay the same. So I got to pick a point where this length and this length are the same, this length and that length have to be the same. So I kind of found a point where all three I'll do some different colors where all three of these lengths are going to be the same. So we'll talk about more later, but notice these lengths are all the same and these are all right angles. So this was a rotation of 90 degrees. So we want to describe the rotation. What direction was it? Here's our pre-image image. So we're rotating 90 degrees counterclockwise. About, now we want to describe the point. About the point, and we can just use our coordinate notation. About the point, x is 0, y is 3. We already talked about isometry in the first phase. We'll just say length is preserved, but for the full definition, see the first page. There's other transformations where they're not isometries. One would be a dilation. Oftentimes you think about your pupils of your eye dilating. It means getting smaller or bigger. The shape stays the same. Angle-wise, it's the same. They're similar, okay? And there's also skewing where you stretch, okay? You take a side and you stretch it out. That's another type of transformation. So there's other transformations, but we are going to be focusing on isometries in this chapter. There's 7.1 homework. Hopefully you don't have any questions on this, but if you do, bring them to class and get them asked. See you then.